Okay, so today I'm going to be teaching about some exponent rules, so let's get started. The first one is x to the power of 1 is equal to x. So if you put any number to the power of 1, then you'll get the same number. So 3 to the power of 1 is equal to 3. The second law is any number to the power of 0 is always equal to 1. So if 3 is raised to the power of 0, that is equal to 1, or any other number. And the third law is x to the power of m times x to the power of n is equal to x to the power of m plus n. So if you're trying to multiply two numbers they have the same base and they might have different exponents, then you can just add the exponents. So in order to see how this works, so if you have 2 to the power of 1, that's 2, and you multiply that by 2 to the power of 2, then that's 4. And 4 times 2, you get 8. Or you can do this, you can add the exponents, you get 2 to the power of 3, which is 8. The fourth law is x to the power of m divided by x to the power of n is equal to x to the power of m minus n. So basically you subtract. If there's ever division, that means you have to subtract the exponents to get like a simplified version. So you could do this as long as the bases are similar. So 3 and 3, it matches, so you can do it with the exponents. So for example, if you do 2 to the power of 1 and divide by 2 to the power of 2, then 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So 2 over 4 is same as is same as half, which is the same as, you can also do this with exponent rules. You can do 2 to the power of 1 minus 2, which gives you negative 1. So this shows another property that we're going to learn. So basically what you do, if there's ever a negative, you just flip it. So, and you put a number. So if it's so it's 2 is basically 2 over 1. So if there's a negative, you flip it. So 1 over 2. 3 over 4, if there's negative 1, 4 over 3. Like that. And we're going to learn about it later on this video. So the fifth law of exponents is that if x is to the power of m and you raise that to any other number like n, then you can just multiply it. You can say x to the power of m to the power of n. So if 3 to the power of 2 is raised to 4, then you can say 4 times 2, you can multiply it, and then you can say 3 to the power of 8, and you'll get the same number. Okay, so the sixth law is x times y to the power of m equals x to the power of m and y to the power of m. So you can basically distribute it, and it's gonna work. So 2 times 3 to the power of 3 is equal to 2 to the power of 3 times 3 to the power of 3. And one mistake you don't want to make is if it's x plus y to the power of m, then you don't want to do x to the power of m and plus y to the power of. For example, if it's x plus y is to the power of 2, then you don't want to do x to the power of 2 or y to the power of 2. You have to. So what an exponent basically is that you're taking this number and you're taking this and you're multiplying this number by itself this many times. So you're taking x plus y and multiplying by itself 2 times. So x plus y times x plus y 2 times, right? You can't really do that. You can't really distribute this because of this operation right here, but you can do it with multiplication, because multiplication is different there, because 3 times 2 is 6, and 6 to the power of 3 is the same as 2 to the power of 3 times 3 to the power of 3. 6 to the power of 3 is 216. 2 to the power of 3, and you multiply it by 3 to the power of 3, that is also 216. But if you try to do that with some kind of addition here, so 2 plus 3, and it's raised to 3, that's not the same as 2 to the power of 3 plus 3 to the power of 3. You can't just distribute it. So you can check 2 to the power of 3. So you can check 2 plus 3 is 5, and 5 to the power of 3 is 125. But if you multiply 2 to the power of 3, which is 8, and you add that with 3 to the power of 3, which is 27, then you get 35, not 125. So you see, don't make this mistake. I've made this a lot. You have to like multiply it by itself. This is how you do it. So and the seventh law is for fractions, x divided by y, all of it to the power of y, then you distribute it, x to the power of m divided by y to the power of m. So for example, you have this 2 divided by 3, then you can do it, you can distribute it, and you can say 2 to the power of 3 divided by 3 to the power of 3, or 8 over 27. And the last one, I showed you this before. If you have a negative number here, you can just flip it. So basically, you can just flip it and you get 1 over x to the power of m. Or here, you can see 3 to the power of negative 4 is equal to 1 to the power of 3 over 4. So you flip it, but you make this positive. So what I like to do is think of it like this, like it's 3 to the power of negative 4, which is basically like negative 1 times 4, right? Negative 4 is negative 1 times 4. So I just use the negative 1 to just flip it. So 1 over 3. And you keep the 4 with the 3. So yeah. And finally, don't make this mistake, because I've made this mistake too many times. And that mistake is negative 3 to the power of 2 and negative 3 to the power of 2. Like, they look very similar, right? And before I would have said, like, they have the same answer. But no, because you have to look for the parentheses. You have to see, like, what's inside and what's included. Because in this one, only 3 is raised to 2, not the negative. And in this one, with the parentheses, you know that the negative is also included and is also raised to the power of 2. So in this one, it's negative 3 times negative 3, which is equal to 9. And you can think of this like with PEMDAS, you know, like remember, like you do the exponents first, then you do multiplication, right? This like multiplication, that's negative. You multiply it by negative 1. So you do this first, which is 9, and you multiply by negative 1, which gives you negative 9. I'm going to be doing some more practice problems to reinforce whatever we just learned. Negative 1 with the parentheses, remember, to the power of 4. So let's write it out, because we have like, let's try to find a pattern first, because there are bigger numbers like on the next problem. So let's try to find a pattern that makes it go quicker. So negative 1 times negative 1 times negative 1 times negative 1. That's 4, right? 1, 2, 3, 4. So negative 1 times negative 1 is 1. And 1 times negative 1 is negative 1. And negative 1 times negative 1 is 1. You see the pattern here? There's 1, negative 1, 1. So if it's like an even number, if it's raised to an even number, then it's going to be positive. So negative 1 to the power of 2, it's going to be 1, right? But if it's negative 1 to the power of 3, then it's going to be negative 1. Because negative 1 times negative 1 times negative 1, negative 1 times negative 1 is 1. And 1 times negative 1 is negative 1. And it's going to go like that for as long as you go. Like, it's an even number, so it's going to be 1. And negative 1 to the power of 5 is going to be negative 1. So let's use that. Is 4 an even number? Yeah, so it's going to be positive 1. Is 10 an even number? Yeah, so it's going to be positive 1. But here we have to be careful because there's no parentheses showing that this negative is included with this. So first we're going to do this, and then we're going to distribute the negative. So 1 to the power of 8 is 1, like, yeah, and then we bring in this negative, which is going to be negative 1. So here we have this, like, 4 to the power of 3, so 4 times 4 is 16, and 16 times 4 is 64. So, and this is an odd number, so it's going to be negative, and negative times negative, it's a positive. Okay, let's move on to number 5 here. So anything to the power of 0 is 1, so yeah, we remembered that. And let's do this one. Negative 2 to the power of 3 and multiplied by negative 3 to the power of 4. Remember, these are not the same bases, so you can't just add them. We have to do it separately. So negative 2 to the power of 3, well, 2 to the power of 3 is 8. And since it's an odd number, then it's going to stay negative, so negative 8. And you multiply that by 3 to the power of negative 3 to the power of 4, which is an even number, so it's going to be positive. And 3 to the power of 4, let's use the calculator because I don't got time, it's 81. And 81 times negative 8 is negative 648. Now that's kind of a big number, but you can use the calculator if you like. Alright, number 7. So it's 10 to the power of negative 8. So what did you learn before? If there's a negative, you just flip it. So it's 1 to the power of 10 to the power of 3. And yeah, this is basically 10 times 10 times 10, like 3 times, so it's going to be 10 times 10 times 10. Alright, so this one, you can distribute it or you can multiply it inside, it doesn't matter, but if there are variables inside, you can use distribution, it might be helpful. But for this one, I'm just going to do 5 times 2, which is 10, and 10 times 10 is 100. For number 9, it's 5 times 2 to the power of negative 2. So we're going to distribute it. Now we're going to do 5 to the power of negative 2 times 2 to the power of negative 2. And then we're going to flip it, so it's going to be 1 over 5 to the power of 2 times 1 over 2 to the power of 2, which is going to give us 1 over 25 times 1 over 4, which is 1 over 100. For number 10, this seems really big, but we're doing only one operation, which is we're going to flip it because there's a negative here. And after that, we can't really do anything else. That's it. So let's do some more problems. These are a bit more complicated. So yeah. So we're going to multiply them. So 3 times 2 is 5. And then x, because they're the same base, we can add them. So we can do, when we're multiplying them, we can add them. So it's going to be x to the power of 5. And that's it. Wait, no, I was supposed to write 6. Alright, let's do number 2. So 4 times 2 gives us 8. And k times k, well, we can add both of these exponents here, which will give us negative 2. So k to the power of negative 2. And this negative 2 doesn't fall under, doesn't cover this 8, so it's not going to touch it. So we're just going to flip this independently of the 8. So 1 over k2, and then we're going to multiply it, 8 over k to the power of 2, and that's the answer. For number 3, it's a division problem, so we can simplify it. So 6 over 8, that's the same as 3. If you divide both top and bottom by 2, it's going to give us 3 over 4, and you subtract these because it's division. So 4 minus 2 gives me u to the power of 2. And since the bigger exponent was up here, we're gonna keep this 2 up here. Okay, number 4, we can distribute this 2, so it's gonna be a to the power of negative 2 times a to the power of negative 4. And now we're gonna flip it times 1 to the power of a to the power of 4. And then we're gonna multiply it. So 1 times 1 is 1. And a to the power of 2 times a to the power of 4. Remember, if you're multiplying, we're gonna add. So a to the power of 6. And this one is just a division, so we're gonna subtract. So it's going to be x to the power of 2 minus x to the power of negative 3, which is going to give us x to the power of negative 5. 2 minus negative 3, which is going to be 2 minus negative 3. So it's going to be 5. So x to the power of 5. Same thing here, y to the power of 7. And then same thing here, z to the power of 9.